Okay, so P7.7, nuclear fission. Nuclear fission means to split, okay? So this is all to do with splitting of nucleuses in two. Okay, and this is the type of reaction that happens at a nuclear power station. And what there are is, in the world, there are two fissile elements, and they are uranium and plutonium. There's only two particular isotopes of these two that can undergo fission, and that is 235 and 239. Okay, so what you need to do is you need to fire a slow-moving neutron at uranium-235, which makes it 236 for a very, very brief period of time. 236 splits in two almost instantly. When it does split in two, it emits 3 neutrons. Now these are 3 fast neutrons, but you need them to be slow neutrons so that they can be absorbed by the nucleus, because if it was a fast neutron, it would just go straight through. Okay, it wouldn't stop. And it needs to be a neutron because the charge of the nuclei is positive. So if it was a proton, it would just get repelled back out again. Okay, just like we saw on the Rutherford scattering experiment. If it was an electron, it wouldn't change this mass number at all because it's too small, it won't make enough of a difference. So it has to be a neutron. And this was one of the things that slowed down the Manhattan Project, was isolating the neutron so that you could slow it down and get it to be absorbed by the uranium. So people could make fission happen, but they just couldn't control it properly because they couldn't isolate that neutron. It was quite a hard thing to do. Okay. Now, when this reaction happens, 3 of these neutrons are emitted, but like I said, they're fast ones when they're emitted from the reaction, so you've got to slow them down. And the way that they're slowed down is that they have to pass through a moderator, and this moderator slows down those neutrons, which allows them to be absorbed by another uranium-235 nucleus. And the moderator in most power stations is water, and what happens there is they slow down those neutrons without absorbing the neutrons, so they travel through them but they just slow them down, and then they can be absorbed. Now, there's 2 types of reaction that you get when it comes to fission, and they are a controlled sustainable chain reaction and an uncontrolled unsustainable chain reaction. And if you only have 1 neutron absorbed, then you get a controlled sustainable chain reaction. So you go 1 neutron in, it emits 3, but 2 of them are blocked, and 1 of them then goes on to cause another one, and then another one goes on to cause another one. So you're creating the same amount of energy all the time, okay? It's not increasing, it's not decreasing. Absolutely perfect for a power station. So what they do in a power station is they use something called a control rod. So a control rod is placed in the reactor, and it will absorb some of these neutrons, and you can raise or lower those control rods. The further in the control rods are, the more of these neutrons they absorb. The further out they are, the less they absorb. So you can increase or decrease the amount of power you generate by how far in the control rods are. So if you stop 2 of them, then it's going to be a completely steady state, 1 in, 1 out. And if you stop 1 of them, it's going to be increasing slightly, and if you don't stop any of them, it's going to be increasing very rapidly. Okay, so, and if it's left to be uncontrolled for too long, if the neutrons all get absorbed, then what you've got is a bomb. Okay. The place where you store the uranium-235 or the plutonium-239 is in something called the fuel rods. So they're the 3 components that you need to know about: the moderator, the fuel rods, and the control rods. The other thing that you need to know is that when you are doing this, it generates heat when these split. That heat then heats up water, which turns, but unlike other generators, so if that was your fuel rods there, in this tank of water, and you're heating this water up, you don't turn that water into steam, okay? Not straight away. It's better to do it this way. So instead what you have is, you have a pipe that is completely separate going through the system, and that pipe of water gets hot, and that pipe of water, that gets turned into steam, which turns a turbine, which then turns a generator. So cold water goes in there, steam comes out, this is your fuel, and this is water. And the reason for that is you don't want this water to escape, because this water has been touching the fuel rod, so it's been contaminated, whereas this one hasn't. So this one can be turned into steam and then released into the atmosphere without causing any damage.